Hello, my name is Victoria Brown, and this is Lab 2, Magnetic Field of a Bar Magnet. Below you will see my glow script code that we will be discussing later. The purpose of this lab is to determine the distance dependence of the magnetic field due to a small bar magnet and compare to that which is predicted by the equations derived from the Beelzebub law. Here are our main findings, which include our values for n, k, mu, and our b net. Some fundamental concepts for this lab include modeling the bar magnet as a dipole, visualizing the magnetic field, the Beelzebub law, in which the magnetic field due to a tiny current element at any point is proportional to the length of the current element. We use this equation to calculate the magnetic field that is produced by a particular current. This equation can be seen below. We then have model linearization as well as distance dependence formula of a bar magnet. The model would be a bar magnet that acts as a magnetic dipole, and for the purposes of this experiment, it is assumed that the magnitude of the magnetic field due to the bar magnet is proportional to some constant times some power of the distance. The x-axis, as defined by your magnetometer app, points along the width of your phone, the y-axis points along its height, and the z-axis points out of the screen. For this experiment, I used the Tesla meter app. Some experimental conditions and methodology for this experiment. Per the lab instructions, the system is going to be the bar magnet and the surroundings is going to be everything else. Methodology. We determine the on-axis field using the x component on the Tesla meter app. We then determine the magnetometer sensor, which can be seen with the images on the left, and determine the distance dependency for a range of values. We then measure the off-axis. Some observations include slight changes in the orientation of the phone interferes with the magnetic field readings. As distance increases from the magnet, the magnetic field in the x direction is close to zero. As the distance decreases from the magnetic field in the x direction is further from zero. Here's the experimental data that was found by using the provided Excel sheet. And so here we have our graph, and we have our B net located in the bottom right corner. Here is the glow script model. On the left, you will see the glow script code, and on the right, we will see the visual representation that was made from this code, as well as our values for the magnitude of B at 45 degrees, which is about 1.39 times 10 to the negative 5. Here are the calculations that I used for this experiment. And so on the left, we have our y equation that was gathered from the previous graph. And from there, we can find n as well as k and use k to plug into the equation, our magnitude equation, to find mu. And with this, we assume that r equals 1. And we end up with 1.74 for our value of mu. Of a data comparison, we have the Excel line equation, in which we have our values for n, k, mu, and our magnitude. And then on the right, we have our theoretical off-axis values for the field, as well as our distance. And below, we have the experimental off-axis values, again with the field and the distance provided. Within this experiment, there is a lot of room for error, such as coding or calculation mistakes, the magnetometer, incorrect orientations, misalignment with the Earth's magnetic field, and interruptions from other devices. So our first what-if question was, what if you hadn't done that and had instead laid out your meter stick at some intermediate angle? with respect to the Earth's magnetic field, how would your results change? It would have been more difficult to correct the measured values, as the X and Y components would have been impacted in the case where the phone was incorrectly oriented. The next question is if we had to imagine we had two identical magnets, and if we redid the experiment but instead using a single magnet, we used the two magnets stuck together end to end. And so the measured magnetic field would increase to nearly double, but it would be important to consider that the second magnet would have an increased distance separation. In conclusion, the bar magnets are a good representation of the magnetic dipole models in which Beelzebub law and distance dependence can be applied. It is also important to note that the distance played a crucial role when it came to determining the strength of the respective magnetic fields. Thank you.